Hi everyone, this is a video about node evaluation, meaning how to get results from intersections, um, roundabouts, or some kind of stretches on motorways. You always need to place a node over that area. The way you place in it doesn't matter too much, so it doesn't matter if it's here or there, or here where you have like links. You can place it like here. It will just get you the data in a different way. Sometimes it can be a problem for you, then consider using each link separately. Depends on how do you want to separate out movements basically. When you have big interchanges, you probably want to model each um, like subjunction or sub-intersection like this. Otherwise, if it's a massive big interchange, you take into account if you want to check like intersection delays and level of services, you probably cannot use such a big node that covers the whole thing because it would count into delay. Like if you have like 4 little signalized intersection within that big interchange, you would count all of that delay in, and that is just not true. So always make sure that when you place the node, place the way it makes sense. You can't have overlapping nodes on the other hand, so just be careful how you deal with it. Um, so that's fine. Let's have a look at the time periods. So I've made this little graph here or illustration. When you model something, you want to have a warm up and a cool off period. They are needed to allow the model to load up basically with vehicles, to be loaded up by vehicles. If you have a long queue or congestion, somebody takes time to build up the congestion before your peak hour starts. Cool off is also important. When the model is over or your peak hour, vehicle still can get to that destination and you can still record everything and do all the measurements needed. Um, I have 4 different scenarios here. If you have a small model and you have an hour, so I assume you have an hour long peak hour or peak period that you are modeling. You had then, if your model is small, you have like 15-minute warm up, 15-minute cool off. It's perfectly fine. If you have a bit bigger model, maybe a short corridor or a couple of intersections, go and have like a half an hour warm up cool off. And you only extract results for the green period, so you don't really, you are not interested or you are not reporting basically as a performance. These ones, you can only or you should only extract data for these just for calibration purposes. When you are setting up your model, but data or results from here should not be used as a performance. So if you need to model and you need to understand what's going on here, you need to model that, and then you need to have a proper warm up before that. When you have 2 hour long peak period, you would extract data for hour 1 and for hour 2. Very rarely you would extract data for each 15-minute interval separately. You would only do that if you have like an event or a school drop off or school pickup or some very peaky where you need to understand what's going on in that 15 minute and you don't want to average the data for the whole hour or you don't want to aggregate the numbers for the whole hour. Okay, go back to Vissim. Simulation. So here you would set up the period. In my example, I have a 15-minute warm up, an hour peak hour, and another 15-minute cool off. So basically like this, yeah? That is 5.4 thousand. You would have multiple runs. In this example, I use 2, but you should always use like 3 at least. But 5 is probably better. When you run your model for results, you should change the random seed with this increment by having here any number, doesn't matter what number, you just put there something so the random generator has a different input in each run. So that provides some variability across your simulation runs. All right, evaluation. So here you want to select, by default Vissim gives you data for all vehicles. If you want the data to be separated out for each vehicle class, you must select them here. You need to hold down Control to deselect or select. You need to make sure that node is selected or ticked. And here you need to put, let me just, so here from time, we are starting at the 15th minute. So this is our example. So we start after 15 minutes, so 900 seconds. The 2 into 2 time is basically when it's over. So that is there. So that is 1, 2, 3, 4, 5. 5 times 900. So that's 4,500. And the interval is that. That is 4 times 900. So 3,600. If you want for each 15-minute period within that peak period, then you go with 900 here. All right. When you go to more, if you don't have any serious congestion on the approaches, I would just use these. But if you have long queues, you need to make sure that you look at these numbers there and increase them to record, to capture basically everything. And you also need to make sure that when you observe the model, the maximum queue should never reach the end of the queue. If it reaches, you extend it. So you want to capture basically the whole queue. Okay, so we set up everything. And just one more thing. So when you go to resource management, you want to select one of these. If you select of current multi-run only, it will remove automatically all previous runs. And that can be quite handy. But if you use all of simulation runs, that keeps all previous runs. And if you have done a lot of half a run here, half a run there, just a few minutes here, few minutes there, that will completely ruin your averaged data. I will show you how to deal with that. So I will select this one, but you can go with that as well. Okay. So now I run it to around 900. So I want to just have, because as you can see now, there is no data. Okay, now we are after 900, but before 900 there was nothing there. There was nothing there. So let me just stop it and now start another one. And I let it to run all the way to the end. So what you see here is you have simulation 10, 11 and average. Then you have standard deviation, minimum and maximum. You would probably want to use average, but standard deviation can be helpful to understand how stable your model is. So if the standard deviation figures are relatively high, that shows that one run is very different to the other one. So a little random input change causes the model to fall over or for vehicles to behave completely differently. So you want a low standard deviation. And now you see we are in the second, 10, 11, 12. And as you see, we are at 758 and there is no data here yet. It will start extracting it from the 900s like that. Okay, let's finish that. And what you want to do, in new Visims, you can filter the data down to average. When you do that, it will take into account the 10th run as well. In our case, that was the first. And that we only run for like, I don't know, 1 minute or two. So it is not full. So when that number, that data set is averaged, that will skew our results completely. So what we need to do once the run is completed, we just delete that run. And how you can do that is done, save. You open the working directory and you go to the results and you just delete all of those runs that you don't need. Just like that. And then you just reopen the model and you will have only 11 and 12, run number 11 and run number 12, and the average only considers those two. You can use filter, or you can filter it to different runs. You probably want to do average. So let's look at the average. And let me quickly go through each attribute. So let me just go to movement, expand it with this little plus, and I want node from link to link. As you can see here, this is a text because I have a name for link number 3. When you extract it, so I hit Ctrl A and Ctrl C it, and you paste it, you see that is there, and there is no columns, no column information on what is what. So you don't want to do this. You want to select copy it with this. Copy. Now if I delete everything here, and if you see it only paste the filter dataset. Now the text is gone, so it is number here, so it can be processed in Excel. And you have columns. So this is the way you want to do that. But if you want a different thing there, you can also remove it by going to movement, go down to from link, and here select only the number. So this way, you can just have the number if you want. Okay, let me just remove that. Okay, so what is movement? The first is the node number. The second is the link number from link with the name of the link, at 9.3. So that means the node is crossing it at the 9.3 meter. Data is only collected when a vehicle, or when the vehicle doing that movement exits actually. So when it completes the trip from this point to that point, when it exits there, when it reaches that point, that is when it is taken into account to the data. Yeah. Okay. QLAN and QLAN max. If you want, you can add unit. It's in meters, not in vehicle numbers. And this is the average Q. This data is averaged across the whole run. So, sorry, the time interval I wanted to say. So when, let's say you have an hour period here, for half an hour, it is 50 meters. For the other half an hour, it is 100. It will be 75 at the end. QLAN max is the maximum within this time interval. Whenever, that means vehicles at least once reach that 364.02 meter long queue. all the way going up there. And this length can only capture queues if you have long enough link. If you have vehicles waiting outside to enter, those are not taken into account there or any day in any data there. If you have a long enough link, but you have in the hundreds the queue, you want to increase these numbers there, yeah? Okay, let me put this back. You have vehicles all, number of vehicles, and I forgot to select, but if you have select these two, let me just quickly run it for a second to have the data so I can show you. Thankfully it runs quite fast now, surprise. Okay, let me just probably it is since we didn't have it before, it doesn't put there automatically, so I need to put there it brings it up automatically if you do it from the start like that. All right, so let me just pause it here. We have some data. So at vehicle, if you see there are all vehicles are in node 1 from link 3 to link 18. So this is link 3 to 18. So basically the right turn from here, you have 188 vehicles, from which 183 are cars, 5 are trucks. You have persons all, and then you have level of service. Again, you can get it for all vehicle types separately. But as you can see, there is an LOS value and an LOS with like the text or a string. They are the same. You should be very careful with that. So again, you probably want to put a node. I'm going to use a section, so I don't want to lose the data. So you want to put a node like this, probably, especially if you have a big intersection, especially a big interchange, especially if you have multiple um, signals within that interchange. Otherwise, the delay would include the whole trip all along. And if it's like hundreds of meters in it, that delay figure would be skewed significantly. To avoid that, you want to set up separate small nodes. Only issue with those small nodes is that you are not going to get a straightforward movement data like an OD metrics data, because otherwise now you have that, for each movement, what is the number of vehicles. So there is a trade-off there because you can't have overlapping nodes. So vehicle delay, this is what you need to use for your LOS calculations, level of service. Just again, if it is a small intersection, small mini roundabout, it's fine to take it. But you want to take it for the total probably. If it is a small, again, if it's a small intersection or something, these are the per movement data. This row is for the total of the node or for the total intersection, like the summary, like an average queue length, all vehicle throughput, and the total LOS for the whole node. When it's a small one, it's probably more representative. Again, when it's big, you don't want to trust that number. You want to place small nodes and calculate it for each approach or each sub intersection basically. You have stops, stop delay, person delay, all kinds of stuff. It's good to compare or if you do some research, but I don't think these are key attributes. These four are emission outputs. these are quite difficult to understand, I think, what they actually mean. There are modules, external modules for Vissim, or a module that is a very easy to calibrate environmental or this emission result process or something. So probably you want to use that. Otherwise, this data is more useful just as a comparison. So like, fuel consumption from one scenario to the other grew significantly. Again, you can set some of these up if fuel consumption and stuff. Read in the help if you are interested in these. I'm not going to dwell more on these now, but I would recommend just to use, if you don't know what you're doing, just as a comparison between each scenario. So that is it basically for Node. Didn't go into the super little detail, but if you're interested in anything more, let me know in the comment section below. If this is something you like and enjoy, please consider liking and subscribing. That would help um, my channel to be shown and not the other videos. Um, and if you want to support me and the channel, you can consider doing that on my Patreon page. It's also in the description below. Thanks a lot for watching and see you in the next one.